Part B says find the nature of the turning points of the curve given by y equals to 3 x squared minus x cubed. Please note that part A and part B are the same. The difference is that they are using different terms to ask the same question. Part A first wants us to find the stationary points and then we distinguish them. But part B just tells us distinguish the points. So in part B, we cannot distinguish the points when we don't know the point. So we first have to find the points, as part A says that identify the points. So part B has given us the curve. Now we need the stationary points of this curve. What do? We find the derivative of the curve. So we differentiate the curve. dy dx becomes 6x minus 3x squared. This is the gradient function of the curve. That gives us the gradient of the curve at any point. We have said that at the turning point on a curve, the gradient is 0. That means at turning points, or at any turning point, at turning points, dy dx is 0. So we substitute for dy dx as 0 here, and then we get the turning point. Therefore, 0 equals to 6x minus 3x squared. I'm seeing quadratic equation here because the highest power of x is 2. Okay, this is a quadratic equation. What can we do? Let us factorize. Okay, let us factorize the right hand side. Or let me first alter. Let me just change the position so that I have 6x minus 3x squared equals to 0. I'll just interchange their position by turning the equation. Now I need to factorize the left hand side in this case. That means 3x is common. So 3x is common. 6x and 3x squared. So here 3x is common. So we'll have into 2 minus x equals to 0. You know how to factorize. So if you don't, go back and look at S.4 Mathematics. This time is this 6x, 3x squared. So we have factorized. So either 3x equals to 0, for which here our x is 0, or 2 minus x equals to 0, for which our x here is 2. So x is 2 here and x is 0. So at the turning points, we have two values of x. This means that there are two turning points. We have a turning point when x is 0 and a turning point when y is 0. Remember, the turning point is a coordinate point. It is defined by x and y. So let us get the corresponding y values in the two cases. So in the first case, if x is 0, what is y? If x is 0, what is y? That means you come and substitute for x in the equation of the curve and get y. So here y becomes, the equation is 3 times x which is 0 squared minus x which is 0 cubed. So here it gives us 0. So when x is 0 at that turning point, the corresponding value of y is also 0. So the point is x is 0, y is 0. So the point is 0, 0. That point is at the origin. And then what if x is 2? What is the corresponding value of y at that turning point? If x is 2, instead we use the equation of the curve to get y. Y equals to 3 times x is 2 squared minus 2 cubed. This gives us here 8 minus 8. Yes. No, it's not 8 minus 8. We have 3 times 2 squared is 12 minus 2 power 3 is 8. 12 minus 8 4. Yes, 4. So at the second turning point, when x is 2, y is 4. So the next turning point is x, which is 2 and 4. Now we have the two turning points. Okay. Now let us tell whether the first point is a point of maximum, is a point of minimum, or it is a point of inflection, as well as the second point. Now, for us to distinguish them, we say that we need to get the second derivative. That is d squared y dx squared. That is what we need to do. So we need to differentiate the gradient function of the curve again. That is dy dx is 6x minus 3x squared. This is the gradient function of the curve. We'll differentiate it again for the second time to give us the second derivative. So d squared y dx squared equals to, if we differentiate 6x, we get 6 minus. If we differentiate 3x squared, we get 6x. Yes. So this is the second derivative. Now, the second derivative will assist us in knowing whether the given points are minimum, maximum, or inflection. So the first point, I'm going to test for it here. We test for this point 0, 0. I'm going to test for the second point here. The second point is 2 and 4. We shall use the second derivative to test for the first point and for the second point. So for the first point, this is x, this is y. So we substitute for x here only. So that d squared y, x squared becomes 6 minus 6 times x. What is x? X is 0. What is 6 times? What is 6? What is 6 minus 6 times 0? Is 6. Now we have that value. Now we judge this value. We say, is 6 more than 0? Is it equal to 0 or less than 0? So if you look at positive 6, it is more than 0. And we say it, if the second derivative is more than 0, then the point is what? If it is more than 0, the point is minimum. Minimum turning point or minimum stationary point. Okay? If the second derivative is more than 0, that point is the minimum turning point. So the point which is 0, 0 is minimum turning point. In the same sense, we need to test for the second point. Now we are very sure that the second point cannot be the minimum point again. Okay? It is now either the maximum point or the point of inflection. Let's see what it is. So remember, we use the second derivative still. So d squared y dx squared equals to, this is x, this is y. Substitute for x in the expression here. So that we have 6 minus 6 times x. X is now 2. That means 6 minus 12 is negative 6. After getting negative 6, let us judge. Is negative 6 more than 0? Is it equal to 0 or it is less than 0? Negative 6 is less than 0. Any negative number is less than 0. And we say that if the second derivative is less than 0, then it is a maximum turning point. If the second derivative is less than, if it is less than 0, then we have maximum turning point. So therefore, this point 2, 4 is the maximum turning point. Are you seeing how simple mathematics is? Very simple. Very simple. So that is the solution to part B, and this is the overall solution to example 2. Mathematics is very simple.